Welcome to the spring semester exam review for pre-cal. And this is going to be the one we're taking in May. So let's go ahead and get started now. The first one, we want to convert the angle to degrees, minutes, and seconds. Now, in order to do that, we're going to have to apply a process. Now, the first thing that needs to be done in order to make this happen, the degrees is given by this part right here. So automatically, this answer is going to be 81 degrees. Now, we separate this part, this 0.96. Let me make sure I keep that point there. The 0.96, in order to make it into minutes, we have to multiply by 60 because there's 60 minutes in a second. And we'll end up with, let me bring out my calculator so you all get the exact values. Let's see, let's open up TI Smart View. And it's going to be something like 57, I think it's 57.4, if I remember correctly, but we're going to double check just to make sure that it is that value. Now, what's going to be important to do after we figure out the value is to get the seconds part. We're going to have to multiply by 60 again since there's 60 seconds in a minute. But let's do this first part. We said 0.96 times 60 gives us an answer of actually 57.6. So that means that in this case, this was our resulting answer. Part that I'm going to take is this part, and that's going to be my minutes. 57 minutes. Now, what I'm going to do now is take this part, the 0.6, multiply that by 60, and that's going to give me an answer of 36, I think. I'll just double check. Oops. Yes, 36. So after that, this being 36 means that this is my seconds format. So I effectively went ahead and came up with the degrees, minutes, and seconds. Fantastic. Let's go ahead and move on now. With this one right here, how to find the area of the sector. In one of your formula sheets, I believe it's in the green one. Let me double check which one it is. Actually, you're going to have to memorize this formula because I was looking, it's not in your formula sheets. It's going to be this value right here. The area of a sector is just 1/2 r squared theta. Now, really important, theta needs to be in radians. Now, luckily for me, this is in radians already, so which means that I don't need to do any kind of conversion. Apart from that, let's go ahead and figure out what the area is by taking 1/2 r squared, which is r is 4, and we have pi divided by 3. Now, after that, it's going to be a simple calculation in your calculator. 1 divided by 2, 4 squared, times pi divided by 3. And we'll have the approximate value is 8.377. Approximate value, A, 3.77, I believe it was 5. Let's double check on that. No, 0.377, actually 8.377, so let's fix that. 8.377. All right, lovely. So there we go. So there is our approximate value of the area for this. So let's go ahead and move on now. So this one, they want you to find the exact value and not use a calculator. Well, with these are going to be somewhat like, if I go ahead, this is going to involve the use of SOH CAH TOA. And what we're going to do specifically with the first one is we're going to use this one, which means that we're going to be looking for the value. Actually, you know what? This one, these are related to SOH CAH TOA, but we're going to get the values directly from the unit circle. So for these, the way we find out these answers is that we're going to be looking for the x value of this degree measurement. So this is going to require a unit circle. So let's go ahead and bring out a unit circle. I'll bring one out for you and kind of describe what's going on with it. Let me go in here. And let me bring out my little, and make sure I do you here, unit. And let's click on this stretch. And what I wanted to do is really just bring out a picture of a unit circle. Now something's going to occur here. that's important that we got to do with this problem. Now, I'm going to put this right over here on the side. Now I'm gonna go ahead and convert this into a fraction where I got whole numbers. This is really 1/3 pi, which means that I'm gonna go three times pi, which means that, okay, here, follow me. 1 pi, 2 pi. So 1 pi, 2 pi. Okay, so this is 1 pi. This when you add another pi, that's another pi. And we're going to go one last one, so we hit 3 pi. So this is important because now after this, I just got to go 1/3 pi, which is this part right here. And that's kind of what you did. Now, and the reason that you know is because of this pi 3. That gives you an idea how much it should move. Now, after that, I'm focusing on these values, and specifically the x value, because x deals with cosine. So they're equal. So in this case, this means that this is really -1/2. Now this is going to be also confirmed by your calculator. If you sit here and you type in, now don't use your calculator because your calculator, remember when you see some of these square roots in the unit circle, they won't come up. But as far as maybe some of the, to see approximation, you could definitely double check with your calculator to say, okay, is this approximately what the square root is? Right here, there it goes, -1.5. So it knows that you have a correct answer and solution. We'll do the same thing here. Now this one's really going to be sine. Let's see, let's go ahead and, now I'm going to clear out some items right here because I want to make sure we get clean history here. But with this one right here, we're going to do the same thing. This is really sine of 5 1/4 pi. That's really what that is. So that means in this case, we're going to go over this 5 times. So here, follow me on this. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And then from there, we're going to go 1/4 pi, which is right here. I'm going to get the x value, -√2/2. Now, if you wanted to see if you got the right answer, an easy check is just to use your calculator. So all you do is do the same thing. Sine 21 pi divided by 4 gives you this -7.7. You might be wondering, is that really, let's see, watch, -√2 divided by 2. Oh, didn't like the way I typed. Actually, didn't like the way I actually had to type the right thing. There you go. All right. Oh, one last thing. I didn't do that right. Should have been looking as I do it. Okay, 2, arrow over to make sure it's separate. You notice that number is the same one as we came up with, which means that this is right. This is the correct value for that value. Now, for this one right here, this last one, we're going to deal with degrees, which is roughly the same thing. If you feel more comfortable dealing with radians now, since we've been working with so much with it, you're more than welcome to do that as well. But in our case, we got to realize that in degrees, this really just represents 360. And it's 720, so it's going to, this is at 720 degrees, 2 pi. Oops. I'm going to go ahead and change that. This is really, at this point, this is 720 degrees. I need to go 30 degrees more, which roughly puts me there. And it wants the tangent. Now, the tangent value for these, you should have them on your unit circle. But the tangent value is really just going to be y divided by x in case if you forget it. But for this one, it's going to be √3/3. And again, you could go ahead and get your calculator and check it out. So there's the question for 5. Let's go ahead and move forward. Now, here they want you to find the exact value. Do not use the calculator. Now, this one is where we're going to be using SOH CAH TOA. You might be wondering, why? Well, because each of these points, a right angle can be formed. Now, the first thing that needs to be done, draw your unit axis. And then after that, plot the point. So roughly, it's going to be here, -3, 4. And then draw me a right angle, because SOH CAH TOA requires the use of right angles. So from here, This is 4, this is negative 3. I'm going to go ahead and fix that a bit. Make sure y'all get a little nice representation there. This is really negative 3. And actually, I kind of wanted, since this thing draws in big ink, that's my theta. Let me do this. I want to make sure y'all get a good vision of this. So I don't want to be limited to the actual, oh, why is it doing that? I think I'm picking black ink. Here we go. Lovely. Okay, so here, let's do this. All right, so 1, 2, 3. Okay, so value's negative 3. 1, 2, 3, 4. So value's 4. Here's my point. The drawing of the right angle. And that means that this is 4. The reason why I wanted to do this is that I wanted to go back over the properties of this triangle. Now, they want me to find this theta value, cosine of it. So specifically, they want me to do this. They want me to go ahead and say, okay, tell me for cosine of theta, we know it's going to equal adjacent over hypotenuse, A over H. Now, the thing is that some of y'all look at this theta and wonder which is adjacent. Adjacent is the one that's next to it. So they call it adjacent. Like if you ever mention your neighbor's adjacent to you, that means your neighbor that's right next to you. Now, you might have a neighbor that's across the street. In math, this is the opposite. You have adjacent and opposite because you got some distance between you. It's not connected. If you physically look at this theta is only connected by the hypotenuse, which is the longest side, and the adjacent side. The hypotenuse is not connected at all to this theta, so that's the reason why it's considered the opposite value. So that gives you an idea. Now, what ends up happening is that this is going to be, I need to figure out what the hypotenuse is. I know what the adjacent is, because I know that this is negative 3. Now, the hypotenuse is going to be found by using Pythagorean Theorem. A squared plus b squared equal to c squared. Now, this is a 3, 4, 5 triangle, but I'll go ahead and apply Pythagorean Theorem anyway. Which means when I mention 3, 4, 5, my answer is going to be 5, because this comes out being 9. 16 is equal to c squared. This becomes 25 is equal to c squared. Take the square root, you find out that c is equal to 5. So really a 5. This is a value of 5. And there's your answer. Now, after this, now they're asking you for this one. Find the tangent value of this. Now, one thing to keep in mind, tangent is this one. Now, if you're having a hard time how this visualizes, you can graph it if you want. The important thing you got to take, though, is that this one, you're actually given all the values for it to figure out tangent. You might be wondering, Mr. Sandoval, can you explain? Okay, let's go back to this that I just underlined. Tangent theta is equal to y over x, or opposite over adjacent, which is also known as y and x. This is x and y. You can go through the process of graphing it, and you'll find out that you'll have, just in the corner grid, this point is going to be somewhere over here in the first quadrant. The important thing to keep in mind is that this x value is 2 over 9. This y value is square root of 77 over 9. So when you're looking for this theta value, this is opposite over adjacent. You're given the values already, which means that this is really the square root of 77 over 9 divided by 2 over 9. Now, this is something important when you deal with this. When you divide these, you've got to multiply by the reciprocal of the denominator. Simply speaking, multiply 9 over 2. Reciprocal. Okay, see that? Reciprocal. Important to know. And then also, this becomes a multiply. I'll draw the little lines. What happens? 9's cancel out. They divide out. You're left with the square root of 77 over 2. And this is your exact answer for this one. Let's go ahead and figure out number 8. It says if the cosecant is theta is phi divided by 2, and theta is in quadrant 3, find the cotangent of theta. Really what they did is that they're very giving you some points here, because you got to think cosecant in itself is the opposite of, it should be, yeah, it's the opposite of sine. And if you're ever in doubt, you can go ahead, your pink sheet does have your formulas. So when you look over your pink sheet and you look at cosecant, the pink, no, actually it's not the pink, I think it might be one of the green ones. Yeah, it's actually one of the green ones that you have that, but cosecant deals with sine. So with cosecant, remember cosecant is just the inverse of these. So this is really hypotenuse over adjacent, or opposite. So really what they're saying is this. Cosecant of theta, this point and where it's located, is equal to hypotenuse over opposite, which means that this is -5/2. Now we're given another part include, it's in quadrant 3, which means that you're given the ability to kind of draw a unit circle. So let me go ahead and bring this down. I'm going to erase up here because I want your focus to now be in this unit circle that I'm going to draw. So we have this unit circle that I'm going to draw. And what we're going to do here is now, this is quadrant 3. And they're saying -5/2, so which means specifically this. You see the negative? The only way that this could be, the only one that's really positive is the opposite, because the other one's going to be negative. And what I mean is this: 1, 2, 3, 4, 5. And then so let's draw, let's say supposing we have this point 2. So far this is what we've been given. This is 2 because this is the hypotenuse side. And since this is the opposite side, is actually, no. Other way around. Let's, we got to fix this. As I'm drawing in, you realize that sometimes it doesn't match to what you're trying to say. And what I'm trying to say is that, yes, we got a negative here, but the negative actually deals with the opposite side. So since this is reversed, that's going to be my -2. So which means that this value -2 is there, -1, -2. This point, we'll put it there. This value is -2. And this value right here is 5. This adjacent is unknown. So why is it important that we know adjacent? Well, because cotangent is the opposite. It's actually x/y. So when I want to figure out the actual answer to this, cotangent is the opposite of tangent. So you know how tangent is opposite over adjacent? This is adjacent over opposite. That's what the cotangent is equal to. I have the opposite. So I have part of the value, but I don't have the adjacent. I can use Pythagorean Theorem to figure that out. Again, the use of a squared plus b squared equal to c squared. C squared is 5 squared. If b, let's see, we have a squared. If b is -2 squared, that means that a squared, hold on. Draw an equals, I'm trying to draw a plus. Plus 4 is equal to 25, -4, those cancel out. A squared is equal to 21. We'll take the square root. We know that a is equal to the square root of 21. So that's lovely, because now I could go ahead and actually come up with the answer. The answer is this. And so just so I don't have to, well, yeah, I'll just write it out again. Cotangent of theta is going to be equal to my adjacent, which we just said it was square root of 21, over my opposite, which is going to be -2. And this is my answer. Lovely. Let's go ahead and move on to the next. Now, I'm going to erase this because I want to make sure you all have enough space for the next one. All right. So now let's go to question 9. And question 9 wants to know if cosine is theta is 3/7 and tangent theta is less than 0, find the sine. So they're telling us a couple of things here. First of all, tangent theta is only negative in certain locations. So we're going to go ahead and actually, let's see, we want tangent theta to be less than 0. Now, let's apply the same idea that we have here, and where we're going to still use SOH CAH TOA. So I'll write it up so you'll have a clear view of what is it that we're working with. So I'm given this cosine theta is really adjacent over hypotenuse, which means that this is really 3 over 7. Now this is going to fit in the unit circle, but it needs to fit in the unit circle when tangent is negative. And there's only a couple of quadrants where it's negative. Tangent is negative, really only 2 quadrants. You'll have quadrant, let's see. You know what I think? Let me go ahead and. So we're going to go ahead. There's a couple of quadrants for tangents negative, and one of them is going to be quadrant 2. You can tell this by looking at your inner circle, and the other one's going to be quadrant 4. So we have 2 quadrants we got to narrow down to, and the reason being is because we need tangent to be negative, and that's how you get a value less than 0. So you might be wondering, well, which of the 2 quadrants do I use? Now, we know something important. This is hypotenuse, this is adjacent. Now, the hypotenuse needs to be positive. Now, since this whole value is positive, it forces this value to be positive. This quadrant is a no, because all the adjacent values, which is all the x values, these are all negative. No, because these are all negative. Okay, so that means it's going to be somewhere in quadrant 4. So 1, 2, 3. And so let's go ahead and draw a point here. Little right angle there. This is going to be 7. This is going to be 3. I have to figure out what sine of theta is. So that means that in this case, remember, sine theta is going to be opposite over hypotenuse. Hold on a quick second. Somebody's not going to. Okay, so with this here, now that we have the necessity, we have the hypotenuse. So we know that part of the answer is actually 7, but we need the opposite answer. We get that by using Pythagorean Theorem. That's a lovely part of this. So a squared plus b squared is equal to c squared. Have 3 squared plus b squared is equal to 7 squared. 9 plus b squared is equal to 49. Minus 9 minus 9. B squared is equal to 40. Take the square root. Now we determined that the b is really equal to the square root of 40, which means that this is really the square root of 40, which means that this opposite is really the square root of 40, and here's your answer. Lovely. We're done with that solution. Now let's move on to the next. So if sine theta is square root of 5 over 3, so let me go ahead and do this first. Let me erase all this here so we can leave some space to figure out the next one. Let's see. Okay. Question 10. Let's go back and I'll do this question 10. Square root of 5, sine theta is square root of 5 divided by 3, and cosine theta is 2 divided by 3. Find the cotangent of theta. So again, this is just using the manipulation of SOH CAH TOA. And the manipulation of SOH CAH TOA just means that we're going to go ahead and just know which parts we've been given so far. Sine theta is opposite over hypotenuse, which means that this is square root of 5 is the opposite, hypotenuse is 3. Cosine theta is adjacent over hypotenuse, and just means that we have 2 over 3. So we know that the opposite is square root of 5, adjacent is 2, hypotenuse is 3 because it matches up on both. Now, cotangent of theta, though, is the opposite is the inverse of tangent, which means you have adjacent over opposite, which means that in this case, we're going to have adjacent, which is here, 2, over opposite, which is here, square root of 5. And we'll have 2 divided by square root of 5. We can't leave it like this because we have to rationalize the denominators when you have a radical. So to rationalize this, We're going to multiply by the square root of 5 top and bottom. And our answer is going to become 2 square root of 5 over 5. And this is your answer at the end. Lovely. Now let's go ahead and move on to the next. It says find the theta values requested for each problem. So for these, we're going to go ahead. Remember, our unit circle can take infinite amount of revolutions. And what I mean is that specifically, we're going to be looking at the same values more than once, just on different circles. Specifically, let me go ahead and share with this one. This one really is 2 unit circles. We're going to have a unit circle that goes from this unit circle. This one specifically is going to go from negative 2 pi greater equal to theta. That's going to equal to 0. And then we're going to have another unit circle that this one's going to be 0 greater than or equal to theta greater or equal less than to 2 pi. So we're going to have 2 of them. And on each of these, we need to figure out when cotangent is equal to 1. Now, cotangent equal to 1, let's deal with this one first. Cotangent equal to 1, you need to ask yourself, when is, which values, first of all, they need to be positive values. When you look at your unit circle, which of these values are going to be 1? It's similar to because remember, in this case, cotangent is x divided by y, adjacent over opposite. There's only certain values that this happens. One of them is here. When you look at unit circle, actually, you know what? Let me bring out 2 unit circles. So I could do that and make it easier for y'all to see that. Now you should have a unit circle next to you, but just to reference a little bit better, I could show you in the unit circles exactly what I'm talking about. Okay, so here's a unit circle, one of them, 2 of them. Okay, let me come back and try to organize these so we could kind of, well, you know what, let me do this. I'm going to do this. I'll make a new sheet here, and let me make out 2 unit circles. I'll then bring out 2 of them. Here's one, here's the other. Let me kind of position them. Okay. Let's talk about the first unit circle. This is the one where we're going to go in the positive direction. So this one's going to go from 0 to 2 pi to cover that length of things. Now remember, we said that we want cotangent to be cotangent theta equal to 1. That only happens when both of them divide. When both, remember, cotangent theta is adjacent over hypotenuse, or adjacent, no, actually, no, adjacent over opposite. So which means that these values, there's only 2 values, which means this is x over y. So x and y need to be the same value in order for it to equal 1. This is x and y. So like at this location, which is the pi divided by 4, that's one of your solutions for this one. Now where else does x and y equal 1? Only one other location, these, because these are both negative of the same value. So there's 2 of my solutions right there. Now when I'm going the opposite direction, same thing's going to occur, except that now it's going to occur at like this value right there. Now what is that value? And remember, this is in the negative, because remember, this is going from 0 to negative 2 pi. So in this case, that value is roughly the same thing as going here. This is negative 3 pi divided by 4. So that's one of my other values, negative 3 pi divided by 4. After that, the other value is going to occur. It's going to be here, where this is negative 7 pi divided by 4. So there's my other value, which means that in our case, I'll go back to my other, we're going to put pi divided by 4. These values, that where does this happen at? Oh, here we go. At these intervals, we're going to go ahead and do pi. We're going to write pi divided by 4. We're going to write it as a set. 5 pi divided by 4. Negative 3 pi divided by 4. And negative 7 pi divided by 4. So those are all the values and where I'd be able to find cotangent theta equal to 1. Now, and now it's asking us for what value is f of theta tangent not defined. So they're asking us, let me Great, we're back. Now, it's asking us specifically, when is tangent theta not defined? Now, remember, not defined, one of the things that's important for us to keep in mind is not defined in math means that we have some number divided by 0. This means not defined. Now, that happens with tangent because there are certain values and where they're trying to ask you to divide for 0. Now, where are these values located at? Specifically, well, let's go back to the unit circle. Let me erase some items that I put in here so we'll have a focus on this. Specifically, where is it at that this happens? Actually, in this case, really only need one unit circle. So let's delete this one. Oh, and bring this one out to the center. And let's make it just a little larger. Well, actually, no, we really don't need larger. But remember, y over x, see how that x is 0? They're asking you to do 1 divided by 0. So in this case, this is undefined. So that means like pi divided by 2, that's the solution. Another place that happens again is also here. The same occurrence that occurs there. So we have 2 places that this occurs. Pi divided by 2 and 3 pi divided by 2. So let's go ahead and write that down. I'll have, it's a little bit lower than this. Here we go. Pi divided by 2 and 3 pi divided by 2. Oh, and actually, the way this is written, they should probably put some limits into it because tangent theta is not defined every time you even add 2 pi to these values. But that's not important. We're going to assume that's going to be just one unit circle. All right, now let's go ahead and move on to the next question. And it says, find the exact value of this expression. Now, what do we have to do here is that we're going to come up with the values. And then from there, after coming up with some of the values, we're going to go ahead and actually deal with the expression of it. So let's go ahead and kind of get started with tangent. Now, with these, you're probably looking at this and then wondering, where do I get started? This right here has a specific radian value. When I ask you for the tangent theta equals square root of 3, right? Okay. So if I ask you for the tangent inverse, that means I have pretty much applied this inverse factor, which cancels out this. So I'm asking you for the radian. What radian is the tangent value of the square root of 3? So let's go ahead and find out what tangent value do we have for the square root of 3. And when you look at this tangent value, it occurs specifically at pi. Now remember, with these, when you look at tangent values, because of the inverses, we're only looking at quadrants 1 through 4. So we're going to look at quadrant 1, which means that this value is going to be pi divided by 3. So if you're looking at pi divided by 3, we're going to go ahead and now figure out what is the cosine of pi divided by 3. What effectively happened? This equals this, because of what I just did right here. So that means that in this case, now look for the cosine value of pi divided by 3, and the x value for that is going to be 1/2. So there you go, 1/2. And that is the answer. Now, this one, they want you to find the amplitude and period of the trigonometric function, question 14. Now, with this, you have to go back to offs. Now, you might be wondering, what is offs? It was an acronym that we use to figure out the oscillation, amplitude, frequency, and also the, it's 2 S's. That's a sequence with it's opposite, amplitude, frequency. Oh god, that S is eluding me for right now for the moment. But let's go ahead and write this in this kind of format right now. Right now there is no O. O is 0. plus amplitude of 1. This is sine 3x. So frequency is going to be 3, but remember frequency, when you have sine, the frequency value as far as the period was equal to 2 pi divided by f. And let me do this. Let me go ahead and actually write it down a little bit nicer. Okay, so S stands for the starting point. Now, as far as this, if I was going to go ahead and break this down, this was offs. This is my amplitude, and this is my frequency. There's no starting point because this is at 0. Starting point would be exactly at the origin. So the important thing we got to keep in mind is that the answer here is that amplitude is 1. Now, in order to get the period is going to be tied into 2 pi divided by f, which means the period in this case is going to be 2 pi divided by 3, which means that this is your period, this is your amplitude, and there's your two answers. Let's go ahead and do the same thing down here. And when they want us to go ahead and find, again, offs in this, if I was going to write this in offs format, this would be 0 plus 5 over 6 OA cosine theta, which would be negative 8 pi divided by 7. Now, technically, you would have to factor out the x. Actually, it would be 0, still on the other side, but this will be your frequency, and there's no starting point on this. So, which means that we're going to have your amplitude is equal to 5 over 6. That's one of your answers. Your frequency, remember, is going to be period is equal to 2 pi divided by f. You got to memorize this formula right here, which means you have 2 pi over negative 8 over 7 pi, which means that when you do this, you got to multiply by the reciprocal of the denominator. So you'll have 2 pi multiplied by, in this case, 7 over 8. Now y'all see these pi's right here? They kind of cancel out. So, because there's two separate values, so I'm going to cancel out that there already. And this is going to be negative 14 over 8. So we get this value here. Because if I left it there, this will really be 1. This will be the reciprocal of this 2, which will be 1 over theta. So let's go ahead and this is your period right here. Okay, fantastic. So that's how you can do those. Now let's find the exact value of this expression. Now they're asking you to go ahead and take the cosine theta of square root of 2 over 2. Now there is, when you do these, you have to realize that the inverse of these only exists in certain quadrants. Like cosines only exist in quadrants 1 and 2. So everything else does not exist. Now, with that in mind, that means that this limits you to quadrant 1. So let me go back to the unit circle. We're going to look for square root of 2 over 2 being positive. Remember, this is no because these are all negative. These do not exist for us. Just quadrants 1 and 2 when you're taking inverses of certain things. So this is going to be your value here, pi divided by 4, which means in this case, when you're figuring out this answer, the answer here is going to be pi divided by 4. Now let's go ahead and now figure out the sine inverse of negative square root of 3 over 2. Now with the sine functions, and this includes also tangent, this is important for y'all to know. One of the things that we learn is that when we take the inverse of it, these quadrants do not exist for it, only these two quadrants. And we're going to be looking at the sine values. So you see how it says right here, sine negative square root of 3 over 2? Okay. When we look at these values, we're not going to put 5 pi divided by 3 because that doesn't exist. We're going to put the negative version of that. So when we go this way, because remember, one of the things we've got to keep in mind is that the sine inverse only exists between square root of 2, negative theta divided by 2 and pi divided, pi divided by 2. Negative pi divided by 2 and positive pi divided by 2. So we're going to have to express this answer as the negative version of this, which means that this is really negative pi divided by 3. So when you write down the answer for this one, you got to keep in mind, or these, one of the things that's important for y'all to keep in mind, that this is going to be negative pi divided by 3. Again, let's review real quick. This one right here, this one goes 0, theta, 2 pi. This one right here, negative divided by 2 pi, theta, 2 pi divided by 2. Virtually quadrants 1 and 2 for cosine, quadrants 1 and 4 for sine and tangent. So you got to know that that's for both of those. So when you express an answer, this being in quadrant 4, you have to express it as the negative version of it. Okay, fantastic. Let's go ahead and move forward with this. Now they want you to go ahead and graph 2 cycles of these functions. So in order to graph these, we got to go back to the OFS formula in order for you to go ahead and successfully do this. Now, remember when we go back to OFS, or OOFS, however you want to mention it, we're going to be looking at these specifically. Let's say frequency x plus shift point. So now in our case, we're going to have no oscillation is going to be or the amplitude. The oscillation is going to be, well, we won't have any. It'll be 0. But we are going to have an amplitude. So we'll have 0 plus negative 3 cosine x. Amplitude will be 3. The value of negative 3. And our frequency, or period, 2 pi divided by f. So which means that period is going to be 2 pi divided by 1. So we're going to go virtually, our frequency is going to be 2 pi. Now since they want, that's our period. Now they want you to graph 2 cycles. So we're going to go from, in essence, when you graph this, we're going to do this. We're going to go from 2 pi, 4 pi. Why? 1 cycle, because of this period. 2 cycles. Okay, that's what it's referring to. So, let me do this real quick. Okay, so with the amplitude part of this, it's going to be specifically affected in the fact that since we have the oscillation equal to 0, we'll have 2 lines that get formed. We get 0 plus negative 3, and y is 0 minus negative 3, which means 2 things. We'll have a line at 3, and a negative 3, another line at positive 3. So that means that here, when you graph this, 3 and negative 3, we're going to be restricted between these 2 lines from there to there. Now, since this is negative, we won't start at the top. We're actually going to start here. Because remember, a cosine at 0 is 1. So this one's going to start actually right below here. And it's going to do this. It's going to shift. It's going to do a complete cycle. So which means that we hit here, 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 and here. We're going to have this complete cycle where you go, it comes back to the same starting location. And it's going to do the same thing again. And there you go. There's a graph for this one. Okay, great. Now let's go ahead and now move to question 19. And question 19 asks us to graph tangent. Erase all this right here. Remember, if you need to, please just go back. You can always go back to the video and just pause it and see what I'm doing. Now move on question 19. Now question 19 is going to ask us to do the same thing. Now remember, with tangents, we have some asymptotes that are formed when we graph these. But we're also going to be using the OFS method to figure out what it is. So with tangent, especially when it asks us to graph this, okay, the first thing we're going to do is I'm going to write down OFS. In this case, OFS. And there's certain locations. Remember how they're undefined in certain locations? That's the reason why we have this idea. Oops. I didn't write OFS the way completely I wanted to have it as F and then S. Okay. So what is happening here? 0, 1. Oops. I want to put equals there. Let's go ahead and put a plus there. Tangent 1 frequency x plus pi. Remember, this is S, starting point. So that means our starting point is going to be shifted plus, basically, by pi. So let me go ahead and have us write down that our starting point is going to be at pi. Our frequency, remember with tangent, the frequency is going to, or the period is going to be found by pi divided by f. So it's going to be pi divided by 1. So which means that, I'm sorry, my period is pi divided by f, which means that we'll have pi divided by 1, so we'll have pi. Okay. Now, one thing that we got to keep in consideration when we're dealing with, when we're graphing it is, and we also have to keep now into account scaling. And scaling is achieved because what we're going to do is that we're going to break up each of our periods into 4. So what we're going to do is that, depending what period you come up with, and do that divided by 4, which means I'm going to do 4 tick marks of pi divided by 4. So now, since I have pretty much everything to start with, now the starting point in our case, oh, I wrote it down already, pi. So let's go ahead and kind of get started with this. I'm going to start, if I call this 0, that's going to be pi. I'm going to start there. And then not only that, but we're going to go ahead and now do the rest, which is kind of, remember, we're going to go by pi divided by 4. So from here, pi divided by 4, if you add it on to pi, that's 3/4 pi. And after that, we hit 2 pi. And then after that, we're going to hit, the last part of this will be 5/4 pi. 5 pi divided by 4. So we went effectively through a whole period. Now you might be wondering, how do we do that? Quarter pi. Actually, no, I'm sorry. Before we hit, I mixed up these two numbers right here. I mixed up a couple of numbers here, actually. Before we hit 2 pi, I jumped ahead too quickly. This is going to be after that. Okay, when we hit not 3/4 pi, because remember, this is really, when we're adding a quarter. Now, let's go back. Let's go back and explain what I'm trying to say in this one. Okay, and it'll be a little bit easier to understand how, especially how I'm coming up with the number. This is really 4/4 pi. So when I do this, this is really 5/4 pi, 6/4 pi, which reduces to 3/2, 7 pi over 4, and then eventually we hit 8/4 pi. This is when we hit a full period right here. Now we need another one. So which means that from here, now, when you draw a period into this, from this location, I'm gonna go ahead and have an asymptote. Oh, and then let me draw my amplitude lines. And we say it goes from 1 to -1. And that's because of A being 1. So when we do that, amplitude is taking your oscillation point, which is 0 in our case, adding 1, y equals oscillation point minus 1 as well. So that's how you get 1 and -1 from those. Now, we are starting from here, and the biggest thing we want to say is that every pi divided by 2 will have a value that kind of shoots up that way. So there's one period right there. We're pretty much going to do the same thing here. 9/4 pi, 10 pi divided by 4, 11 pi divided by 4, 12 pi divided by 4, and that's, we end it there because we hit another pi. From here to here, this is another pi value as far as difference. So here's my asymptote for tangent, another value there, and we draw two cycles of this. Lovely. Let's go ahead and move on to the next one. And do the same thing for this one right here. We're going to have y is equal to the amplitude. Remember, this offs 1/3 x. In this case, we're going to have 0, 5 sine 1/3 x. Oops. Actually filling in values in a sense. Amplitude. This really should be frequency. I think this is what I meant to write, but and starting point. So remember, this is frequency. There's not going to be any starting point in this case. So amplitude is going to be 5 period 2 pi over 1/3, which means that in this case, this is really 2 pi multiplied by 3 over 1, which means we have a period of 6. And my tick marks are going to be created off my period divided by 4, which means I'll have 3/2 pi as far as tick marks. So let's draw this one. Now this one, when I draw it, first of all, I'm going to draw 2 cycles of it. First cycle will be 6 pi. Second cycle will be 12 pi. I'm going to go off tick marks of 3/2 pi. So I'll have there. So this is 3/2 pi. I'm going to add that 6/2 pi, 9/2 pi, 12/2 pi, 15/2 pi, 18/2 pi, 21/2 pi. All I'm doing was adding 3 to them. Now, as far as my amplitude, on both of these, my amplitude is going to be, remember, it's going to get 2 lines. One is you're going to take our oscillation point, which is 0, add 5 to it, and take our oscillation point, which is 0 again, subtract 5 to it. This is going from -5 to 5. Now, this is a sine function. Now, remember, you got to keep in mind of how these behave. It starts off at 0, sine does. And the reason being is when you look at the unit circle, you look at the y values, they tell you. With cosine, it starts at 1. So that's the reason why you have something that's different on that one. But in essence, you're going to end up at the same place. Remember, you're going to hit here, here, here. When you have sine, you'll have these hitting points. And then you'll have the same thing occurring as far as the y values. Remember, specifically just looking at the y values. So there's 2 sections of it here. Okay, let's do the same thing with this one. Remember, this is oofs. And actually what I'll do is I'll draw this one. Actually, I'll do exactly minus s, which means this is... All right. Now, let's go ahead and do this one. Okay, good. Now, one quick correction I want to make as I'm realizing this. On this tangent one, I want to point something out. This being positive means that in reality, everything should have been, the starting point should have been the negative version of that, negative pi. So instead of starting at pi, imagine like if everything was shifted, all this thing was shifted over here to negative pi. So just move this whole thing to negative pi this way and start from there and do exactly all we did there as far as those 3 points. Now let's go ahead and go back to this. Yeah, oh, yeah, no worries.